Hi again and welcome back. This is Terry again. We're going to continue on in what we talked about in the last lesson. We were talking about evaluating, and I mentioned there that we were going to use this idea of evaluating to help us to do something that we needed to do. But we're going to go back and review a little bit first to make sure we've got all the information we need. If we have an equation looks like this, n minus 3 equals 5. That's called a linear equation in one variable. You can see that, right? Because we only have one variable. The solution to that equation. Remember what a solution is. A solution is what works, and that's true in anything you're talking about. Same way in math. And the way we found this, because we know how to solve equations now, we used to add 3 to each side, and that number that we needed was equal to 8, because in fact 8 minus 3 is equal to 5. So 8 is in fact a solution because it works. Now, does anybody remember, we talked about this before, about how we graph that? You remember we had a number line, and we had a reference point on our number line, a beginning point, and because it was the beginning point, we called it the origin. Remember that, the origin? And to find a visual representation of that number, we went over here 8 units to the right, 8 in the positive direction. We put a dot there, and then anybody could look at that and see, okay, that's the graph for the solution to this equation. Okay, do you remember that? If you've forgotten it, go back and review so that you're clear on it, so you know what we're going to do. Now, we're going to go on with what we talked about last time, about those situations where we have pairs of numbers that have to go together. I don't know if you remember or not, but we talked about complementary angles. That's two angles, the sum of whose measures is 90. And we were given one angle, this is what it looks like. 2 angles add together equal 90. And we talked about, if you remember, if not you can go review it, when y was equal to 35. In other words, when this angle here is 35, you remember we evaluated by putting that number in there. We solved the equation and we got a value for the other angle. And it turned out to be, because we have to do the same thing to both sides, that angle is 55. Now, if I pick 35 as one of my complementary angles, there is one and only one angle that can be complementary to that. And we just found it here. So these 2 angles have to go together. Now when we talk about situations where a pair of numbers, specific pairs of numbers, have to go together, what we're talking about is paired data. Data is just numbers, and paired, of course, it's not like the kind you eat, the fruit you eat, it's the ones that have to go together in twos. Paired data, a pair of numbers that have to go together. Well, to kind of help our brains get a hold of this idea, we had to come up with a way to write something that would show that these 2 numbers have to go together. Well, in math, we've got a symbol that helps us put things together in a group. You remember what it's called? Parentheses. Okay, so we put parentheses around those numbers. I'll do it down here. So I've got 50, 55, and 35. But if you look at that, 5535, your brain's not going to see 2 numbers. It's going to see 5,535. So we've got to separate them. So what we do is we just put a comma. Now just take a look at that for a second and see if your brain doesn't kind of tell you, well, those two got to go together because they're in a group. And of course I got to put the comma there so that I see that there are actually two numbers. And so this is just one example, and there are lots of examples where we deal with pairs of numbers that have to go together. What we want to talk about, at least in an introductory kind of form today, is we want to talk about graphing situations where we have paired data. Now remember, when we just had one variable, in that first example we used, n minus 3 is equal to 5. When we do the picture representation that, we did a number line. One variable, one number line. One variable, one number line. Now you wonder why I'm saying that. Well, stop and think about it for a second. Remember, we've kind of noticed as we've started through here that there are patterns in math. And when you learn the patterns, you learn to look for patterns. It helps you because you don't have to relearn everything every time things change just a little bit. You look for the patterns, you adjust the pattern for the new situation, and you already know a lot of the information that you need. So let's think about this. When we had one variable, we had one number line. Thinking of patterns, what do you think we might have if we have two variables? Okay, two number lines. But we've got a special situation here, and it requires us to look at this and make some special, fit some special requirements. I know that the numbers that I'm thinking about have to go together. So when I draw my two lines, each one to represent a different variable, I want them to go, I want to be able to look at it and see these numbers have to go together. So the way I can do that with lines is I can draw them so they intersect. But I can intersect two lines in a lot of different ways. And so I want something that's going to be unique. So I know this is the only way I can do it. Well, there's one situation where that happens, and that's if we draw our two lines so they are perpendicular. And that's what we do when we're dealing with situation where we have two numbers. One line is going to be horizontal, and remember how we did it with 8? We went over 8 units to the right. Well, we're going to do the same thing for that part of our answer, for that one number. So we're going to one of the numbers is going to represent how far we go horizontally. The other is going to represent how far we go vertically. Well, when they did this, they called this the x-axis and that the y-axis. This x-axis is very much like the number line we used before, and so why not just keep things the same? To the right is positive, to the left is negative. Well, then what do we do about the vertical? Let me give you an example. If you're on a cliff, and the cliff drops straight down 1,000 feet, and you step off that, is that going to be a positive or negative experience? Okay, so if we go this way, horizontally, that's positive. This way is negative. Down is negative, and up would be positive. And that kind of makes sense anyway, because when we're up, we're positive. Okay, so this is going to be positive. Now think for a second about why they might have decided to call the horizontal axis the x one and the vertical axis the y one. And also, when we get a pair of numbers, let's say we have a pair of numbers 3 and 4. Now, right now we don't know what those numbers relate to, but whatever it is, some situation, we've got a pair of numbers that are related in such a way as 3 and 4 are going to be the numbers that we have in question. Which one do we do first? Do we do the horizontal one first or the vertical ones? In other words, is this going to be xy or is it going to be yx? Well, there isn't really any strict requirement. I guess you can make it whatever you want, but in order to make it easy, so it would be easy to remember, what the determination was made is, let's go ahead and make the horizontal one x and the vertical one y. The first one x, the second one y. Now, why would that make sense? Don't complicate this. Your brain can complicate anything, but don't complicate this. It's simply because x comes before y. And why the horizontal one is called x and the vertical one is called y? Anybody have any idea about that? Well, if you go look in the dictionary, guess what? Horizontal comes before vertical. Now that's just intended to help you remember which is which. So just keep that in mind. Now, this point right here, where those two lines intersect, it has to be represented with a 0 for each one of those lines. Because at that point, you haven't gone anywhere horizontally, you haven't gone anywhere vertically. It's still called the origin, though. Okay? So if I have a pair of numbers, well, let's see if we can think of an example. Let's say that we have, let's see if I got it. Okay, let's say we've got this one. This is going to be our equation that we're going to use. Let's just erase this here so it won't get in the way and confuse us. We've got x plus y equals 6. Tell me a pair of numbers that would work there. Okay? What this says is I want two numbers that add up to 6. So it could be 5 and 1. It could be 4 and 2. It could be 3 and 3, and so on. All they are is a pair of numbers that add up to 6. But when I have the 5, can there be anything there but the 1? And when I have the 4, can there be anything there but the 2? Now, it's important to understand something else here too, and that is we're going to be talking about situations where x and y are related to specific ideas. And so if I have 5 plus 1 equals 6, I'm saying that the x is 5 and the y is 1. Well, what if it turned out that the, see if I can get my hand to write it down here. No, but it's the same thing. See if I could get it, if I said my x was 1, would my y have to be 5? Yes. Okay, so let's take a look at these pairs of numbers and see how we graph them. If I take this one first, remember, the first one is horizontal. It's x, but it's horizontal for the same reason. Horizontal comes before vertical. So I'm going to start at the origin, my beginning point, and I'm going to go 5 units horizontally. So I'm over here. Now I've got to make a decision. I've got to do something to make sure these two numbers go together. Well, what happens if I come back over here and go up 1? Now I've got 2 points there. Do they look to you like they're tied together in any way? Okay. They look completely separate. There doesn't seem to be any connection. Maybe we could make some connection, I don't know, but it isn't obvious, and we want things to be obvious. So what we do, rather than that, is we go over here to the 5, and then instead of going back, we move vertically from there. So I go up to this point right here. Now take a look at that and see if you can visualize for yourself that that pair of numbers relates to that. I go over 5, up 1. Okay, if I look at this one, 4, 2, I would go over 4 and up 2. This one would be 3, 3. I would go over 3 and up 3. Does anybody notice something happening there? Absolutely. All three of those points are on the same straight line. This one here, 1, 5, is over 1 up 5. Well, if I draw my points a little more accurate, it'll look better. Let me get those. So, anytime we have an equation that looks like that, x plus y, well, this is the way we write it. ax plus by equals c, where a, in this case, the a is 1, the b is 1, and the c is 6. Anytime we have an equation that looks like that, when we draw a graph of that, or when we find the points on it, every single point on that line that if we connect these, we can see this. Every single point on that line is going to have a pair of numbers, remember paired data, and those two numbers are going to add up to 6. Now this point over here would be 6, 0. This point up there would be 0, 6, because no horizontal, 6 vertical, 6 horizontal, no vertical. So that's what we get. And remember that these two are different points. That's where we get the idea of ordered pairs of numbers, because the order does matter. Now this is basically just an introduction. We're going to go into it in more detail, but spend some time with this and get used to this idea of how we graph numbers when we've got paired data, two numbers that have to go together. Let's just quickly, before we move on, let me just give you some points and let's go through and see where they are. If I've got these four numbers, I've got 2, 1, I've got minus 3, 5, I've got minus 4, minus 2, and I've got the fourth one is 5 minus 2. Just remember, horizontal comes first. So when I look at this one, I'm going to go horizontal 2, vertical 1. So it'll be right there. This one, I'm going to go negative 3 horizontal. 1, 2, 3. And then I'm going to go 5 vertical. So there's negative 3, 5. This one would be negative 4. Negative 2 is negative 4 vertical, negative 4 horizontal, and negative 2 vertical. Instead of trying to think x and y, I think it's easier to keep your brain straight if you think horizontal, vertical. Horizontal, vertical, and lastly we've got 5, negative 2 would be down there. So spend some time, because we're going to go on from here, spend some time so that you make sure you know what this is all about, the idea of paired data, and then how we find the picture representation of the pair of numbers, horizontal, vertical. And I'll look forward to seeing you then. Thanks for coming today.